Okay, so this is the second topic that I want to cover. And
Okay.
what is the meaning of this average atomic mass? So, have we understood the concept of isotope?
Yeah.
Just to review the concept of isotope again. Now, this is the same NCRT PDF. This is from chapter 2. Yeah. So
Okay.
again, if you see, they tell you something about isotopes, and if you see, they'll give you a few examples of isotopes also. So, for example, considering hydrogen atom again, 99.985 hydrogen atom contain only one proton. So this is the isotope called protium. Rest of
Mm-hmm.
the rest of the percentage of hydrogen atom contain two other isotopes. So hydrogen has three isotopes. You can write these down. So first would be
Okay.
protium. First would be protium. First would be protium. Second would be deuterium, and the third would be tritium. Can you note these down?
Yeah.
And the nomenclature that is followed is X, A, Z, where A is the mass number. So mass number is written above, and the mass number is written above, and the atomic number is written below.
Yeah.
So I will write protium as 1 1, deuterium as 2 1, tritium as 3 1. Are we clear about this?
Yeah.
And like we have discussed before, the difference between the three isotopes of hydrogen would be that hydrogen, protium, deuterium, and tritium,
Mm-hmm.
number of protons, neutrons, electrons. The protons would remain one. Have you understood what I said?
Mm-hmm. Yeah.
The electron would also be one. It is only
Mm.
the number of neutrons
Neutrons.
that will differ. Are we clear about this?
Yeah.
Now the issue is that in nature 99.985% would be the first, the protein. So this would be
Mm.
99.985%. And then if you see the rest, the deuterium is 0.015%,
Mm-hmm.
and the other possessing is tritium. Have
Mm.
we Are we clear till here? So
Yeah.
if you see tritium would be negligible. Are we
Yeah.
clear till here? So these are the three isotopes of hydrogen, and because it is
Mm.
mentioned in the textbook, we should remember these, the name of the three isotopes of hydrogen. Then if we
Okay.
see, like we have discussed just before, carbon will occur in three isotopes, C12, C13, C14.
Yeah.
Similarly, fluorine will have two isotopes, fluorine 25 and fluorine 37. Are we clear till here?
Yeah.
And they have told few properties of isotopes, because the chemical properties of isotopes are dependent upon the number of electrons, and the number of electrons are the same. So in isotopes would have the same chemical properties. Are we clear till here?
Yeah.
The number of neutrons present in the have very little effect on the chemical properties. Are we clear till here?
Yeah.
Yeah. And now let us come back to how you know this topic becomes important for us when we are talking about the atomic mass. This is our focus. The issue is that if you see the example of carbon, now
Mm.
we selected carbon 12 and made it the standard कि
Mm.
भाई तुम जो हो तुम तो हो गए भाई standard. But the problem is,
Mm-hmm.
Now, if you try to understand, the problem is that in nature, carbon 12 is only 98%, 98.892%. There are other, flavors of carbon also which are present. So we have flavor of C13 also, we have the flavor of C14 also. So in the periodic table, just try to understand, in the periodic table, I can give atomic number to carbon, which would be 12, because 12 is atomic number of carbon. The number of protons, the number of, I'm sorry, the atomic number of 6 I can give to carbon, because the number of protons and number of electrons of all these three flavors are the same. But the problem becomes, what is the mass that I give to carbon when I am making the periodic table? Is it making sense to you?
Yeah.
Let me state this again. So when I'm making a periodic table, when I'm making periodic table, so all the elements are there. Now because the atomic number is given as per the number of protons, and number of protons is equal to number of electrons for a neutral atom. So I can give, you know, for atomic number, each element would get a unique number. But the problem is when an element comes in two or three or more flavors as per the number of neutrons, the problem becomes what is the mass that I give to a particular element. So what they decided was that as per the occurrence, as per the relative abundance, these are the two words that they use. So as per the abundance of that particular isotope in Earth's crust, they will be giving a weighted average of the mass. Is it making sense?
Yeah.
So if you see closely, C12, because it is standard, is given 12 atomic mass unit. Is it making sense?
Yeah.
C13 would have 6 protons and 7 neutrons. It would have atomic mass unit of 13. And C14 has 6 protons and 8 neutrons. So it has given atomic mass unit of 14.00317 units. Is it making sense?
Yeah.
And now, as per the abundance of the different isotopes, a weighted average is calculated, and this is how it is done. Do you see this point 98892? This is this percentage. This is this percentage, and
Okay.
this is this percentage. Is it making sense?
Yeah.
So this is the average atomic mass of carbon, where the percentage abundance of the three flavors have been taken into consideration. Is it making sense?
Yeah.
So usually they'll ask you one of the question they usually ask is about chlorine. So chlorine, they give you the relative abundance, they give the atomic mass unit of the two flavors of chlorine, and they ask you the how to calculate the average atomic mass of chlorine. Is it making sense?
Yeah.
I will try to find that question. Are we clear till here?
Okay.
Are we clear? Are we clear that how these average atomic mass
Yeah.
unit, or one of the question that is asked is fractional atomic mass unit. Explain the fractional atomic mass units, uh, fractional atomic masses of elements. This is another way in which this question is asked.
Mm-hmm.
Is it making sense now?
Yeah.
Okay. And there's a one small topic that I want to cover is the difference between the molecular masses and the formula masses.